Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side AD equals to 3 units, side DC equals to 6 units, and side AB of quadrilateral ABCD equals to 5 units. We also know that angle ADC equals to 90 degrees, angle DCB equals to theta, and angle ABC it is also equals to theta. And we want to find out the length of line segment BC that is actually equals to X. So we want to find out the length of line segment X that is equals to BC. So we start with the first method. In the first method, we will extend side PA and side CD until they intersect with each other. So the intersection point or the touching point between extended line segment BA and extended line segment DC will be defined as E. Again, point E is the touching point between extended BA and extended line segment CD. Okay, so here we actually created triangle EBC. And we actually have rule number 1. According to rule number 1, in front of equal angles in a triangle, there are equal sides. In front of equal angles in the triangle, there are equal sides. So I'll read rule number 1 again. According to rule number 1, in front of equal angles in the triangle, there are equal sides. So if we focus on triangle BEC, in triangle BEC, we know that angle EBC, this angle, is equal to angle ECB, this angle, and both angles are equal to theta. Repeat again, in triangle ECB, we know that angle EBC equals to angle ECB equals to theta. Therefore, according to rule number 1, in front of those two equal angles, there are equal sides. So here, in front of this angle theta, we have side EB. In front of this angle theta, we have side EC. So EB equals to EC according to rule number 1. Okay, EB equals to EC. So EB equals to EC according to rule number 1. EB equals to 5 plus AE. So we substitute EB by 5 plus AE. EC equals to 6 plus ED. So we substitute EC by 6 plus ED. Here we will subtract 5 from this equation and we'll get that AE equals to ED plus 1. Okay, so we will define ED as A. So here side ED equals to A according to our definition. So here we will substitute ED by A and we get that AE equals to A plus 1. AE equals to A plus 1. So here side AE equals to A plus 1. Actually, we know that BEC is triangle. Therefore, and EC is one side, line segment EC is one side of triangle EBC. So EC, if a side of a triangle, must be a straight line. Okay. So here EC, actually we created line segment EC by extending line segment CD by a straight line, and when you extend a straight line by straight line, the result will be a straight line. For that reason, only for that reason, EC is a straight line. In addition, EC is one side of triangle ABC, therefore it is absolutely a straight line. Okay, so we can write down that EC is a straight line. Line segment EC is a straight line. And we have also rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. I will write it down. The sum of the angles I'll repeat on rule number 1, or rule number 2. So according to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So according to rule number 2, if you focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. So at point D, on this side of the straight line EC at point D, the sum of the angles must be equal to 180 degrees according to rule number 2. So which angles we have at point D? This is the right angle, so 90 degrees, plus the size of this angle, that is actually angle EDA, angle EDA, in total, the sum of those two angles must be equal to 180 degrees according to rule number 2. I'll repeat again, if we focus on this side of the straight line EC at point D, then the sum of the angles here must be equal to 180 degrees. That is to say, at point D we have 90 degrees plus angle EDE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Okay? So we subtract 90 degrees from this equation, and we will get that the missing angle EDA, equals to 180 degrees minus 90 degrees, it is 90 degrees. So this angle EDA equals to 90 degrees. So if angle EDA equals to 90 degrees, it means that triangle EDA is a right triangle. That is to say, we can implement the Pythagoras theorem on the right triangle EDA. So in the right triangle EDA, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here, by PT is evaluation for Pythagoras theorem. So according to the Pythagoras theorem, in the right triangle ADE, the square of the hypotenuse is AE squared. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to AD squared plus ED squared. I'll repeat again. According to the Pythagoras theorem, in the right triangle EDA, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AX squared equals to AD squared plus ED squared. So according to equation number 1, AE squared equals to AD squared. AD equals to 3 according to what is given as the question. So AD squared is 3 squared, that is 9. That's it, and plus ED squared. Plus ED squared. ED equals to A according to our definition. So ED squared is A squared. So from now that AE squared equals to 9 plus a squared, but a equals to a plus 1. So we can substitute ae by a plus 1. So ae equals to a plus 1, so a squared is a plus 1 squared. And according to equation number 1, it is equals to 9 plus a squared. Here we will open the brackets on this side of equation number 1. And we get that according to equation number 1, a plus 1 squared equals to a squared plus 1 plus 2a, and it is equals to 9 plus a squared. Here we have a squared on both sides of equation number 1, so a squared will get cancelled. And we'll subtract 1 from this equation, equation number 1. And we get in this side of the equation 1 minus 1 is 0, so here we have only 2a, that's what is left, and in the other side of equation number 1 we have 9 minus 1 is 8. So in conclusion, we found out that according to equation number 1, 2a equals to 8. Here we divide this equation number 1 by 2, and we get that according to equation number 1, a equals to 4 units. So here we can write down that a equals to 4. Therefore, a plus 1 will be equal to 4 plus 1, that is 5. Okay, so actually we define angle BEC as alpha. So if we focus on the right triangle AED, in the right triangle AED, what is the value of cosine alpha? Here cosine alpha equals to ED over AE. Cosine alpha equals to ED over AE. I repeat again, in the right triangle AED, cosine alpha equals to ED over AE. We have already found out that ED equals to 4, so we substitute ED by 4, and AE equals to 5, so we substitute AE by 5. So in conclusion, we found out that cosine alpha equals to 4 over 5. Now we can implement the law of cosines in the big triangle ABC, in the big isosceles triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. So if we have triangle ABC, that could be any triangle. This is triangle ABC. We know that side AB of this triangle ABC equals to A unit in its length. Side AC equals to B unit in its length. And side BC equals to C units in its length. And the angle between side AB and side AC is alpha. Then according to the law of cosines, that is true in any triangle, as I already said, we get that c square equals to a square plus b square minus 2 times ab times cosine alpha. We will add 2 times AB cosine alpha to this equation, and we will subtract c square simultaneously, and we get that 2 times AB cosine alpha equals to A square plus B square minus C square. We'll divide this equation, equation by 2 times AB, and we get that cosine alpha equals to A square plus B square minus C square over 2 times AB. Okay, so we can actually implement the law of cosines in our drawing. In our drawing we have this angle alpha, that we know that cosine alpha equals to 4 over 5, 0.8. So here, according to the law of cosines, we get that cosine alpha in triangle ABC, in triangle EBC, cosine alpha, according to this equation, equals to EB square plus EC square minus BC square over 2 times EB times EC. So this equation is the implementation of the law of cosines in the right triangle and triangle EBC, our triangle EBC. Okay, cosine, we already found out that cosine alpha equals to 4 over 5. So we substitute cosine alpha by 4 over 5, and it is equal to EB squared. What is the length of EB? EA equals to 5. AB equals to 5. EB equals to EA plus AB. That is to say, it is equals to 5 plus 5, that is 10. So we can write down that here that EB equals to 10. And EC also equals to 10 because it is an isosceles triangle, but you can see here that 4 plus 6 is also equals to 10. So EB equals to EC equals to 10. So here EB squared is 10 squared, that is 100, plus EC squared, that is also 10 squared, that is also 100, minus BC squared. BC equals to X. This is the missing line segment that we are looking for. So BC squared is X squared over 2 times EB is 10 and EC is also 10. So here we get that in the denominator on this side of the equation we have 10 times 10 is 100, and 100 times 2 is 200. So we will multiply this equation by 200, and we get that 4 over 5 times 200 equals to 100 plus 100 is 200 minus X squared. Here 200 over 5 is 40, and 40 times 4 is 160. That is equals to 200 minus X squared. Here we will add X squared to this equation, and we will also subtract minus 160. And we get that according to this equation, X squared equals to 200 minus 160 is 40. So x squared equals to 40. We will take a root out of this equation and we get that x equals to the square root of 40. 40 is 4 times 10. The square root of 4 is 2, so in conclusion, we found out that the length of line segment x, it is equals to 2 times square root of 10 units, so in terms of numbers, it is equals to 6.32 units. I'll repeat again, the length of this line segment BC that is equal to x, it is equal to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. In the next step, I will present to you how to find out the length of this line segment here. The length of this line segment x, according to the second method. Okay. In the second method, we'll do another construction from point A. We'll draw a straight line on DC. I'll repeat again, from point A we'll draw a straight line on DC in such a way that it will be perpendicular to BC. Here we draw the straight line AE in such a way that is perpendicular to side BC of quadrilateral ABCD. So here, according to our construction, AE is parallel to BC. I'll repeat again, actually, we drew the straight line in such a way that AE is parallel to BC. AE is parallel to BC according to our construction. And from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. We define the touching point of the straight line from point E and BC as F. So I repeat again that we draw the straight line EF in such a way that EF is parallel to AB. EF is parallel to AB according to our construction. And AE is also parallel to BC, also according to our construction. It is something that you can do. It is not a problem at all to draw a straight line in such a way that it will be parallel to another straight line. Okay, so this construction is possible. So here we have, we know that AB is parallel to EF. AB is parallel to EF. And we also have rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. I read rule number 3 again. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here we know that AB is parallel to EF. According to our construction, AB is parallel to EF. Therefore, according to rule number 1, those two angles that are corresponding angles that are located between the parallel lines AB and EF will be equal to each other. That is to say, this angle, angle ABC, must be equal to angle EFC, this angle, I repeat again, because of the fact that according to our construction, AB is parallel to EF, we can derive from it that angle ABC must be equal to angle FEC. Why? Because those two angles are defined as corresponding angles and they are located between the parallel lines AB and EF, therefore they are equal to each other according to rule number 3. But according to what is given us in the question, angle ABC equals to theta. This angle equals to theta according to what is given us in the question, so we can write down that angle ABC equals to theta. And from this equation, theta equals to angle ABC equals to angle EFC, we will derive that angle EFC is also equal to theta. So here we can write down that angle EFC equals to theta. This is actually according to rule number 3. So here, likewise, according to our construction, AE is parallel to BC. Okay? Okay? According to our construction, AE is parallel to BC. Alright, yeah. This is according to our construction. Therefore, according to rule number 3, because of the fact that side AE is parallel to side BC, those two angles that are defined as corresponding angles that are located between the parallel lines BC and AE must be also equal to each other. That is to say, angle BCD, this angle BCD or BC, it doesn't matter. So I call it angle BCD. This angle is equal to this angle that is actually angle AED. I repeat again, because of the fact that AE is parallel to BC, angle BCD must be equal to angle AED because there are because those angles, there are two corresponding angles that are located between the parallel lines AE and BC, therefore they must be equal to each other. Okay? Those two angles are located between the parallel lines BC and AE, therefore they must be equal to each other. But according to what is given as the question, angle D and BCD equals to theta. This angle equals to theta according to what is given us in the question. So this angle equals to theta. So from this equation, we will derive from this equation that theta equals to angle BCD equals to angle AED. We will derive that angle AED is also equals to theta. Angle AED is also equals to theta. So this angle AED equals to theta. Okay. So here we created quadrilateral ABEF. This quadrilateral is a parallelogram. Okay. This quadrilateral is a parallelogram. I will write it down. Quadrilateral AEBF is a parallelogram. Okay? Why? Because any quadrilateral that has two couple of sides that are parallel to each other is defined as a parallelogram. And in this quadrilateral AEBF, we know that AB is parallel to EF, and we also know that AE is parallel to BF, therefore this is exactly the definition of a parallelogram. Okay, so quadrilateral AEBF is a parallelogram. And we also know that the opposite sides of a parallelogram are equal to each other. So this will be rule number 4. The opposite sides of a parallelogram actually are parallel to each other and also equal to each other, okay? So according to rule number 4, the opposite sides of a parallelogram are equal to each other. I'll repeat on rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So in parallelogram AEBF, in our parallelogram AEBF, here P is the abbreviation for parallelogram. So in parallelogram AEBF, the opposite sides are equal to each other according to rule number 4. That is to say, AB must be equal to EF. AB must be equal to BF according to rule number 4. AB equals to EF. Here AB equals to EF. Here AB equals to EF. According to rule number 4. AB equals to EF. But AB equals to 5 units. This is given us the question. So we can write down that AB equals to 5 according to what is given us in the question. So from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF equals also to 5 units. Here we can write that EF equals to 5 units. So we will focus on triangle EFC. In this triangle, we have two equal angles. Those two angles are both equal to theta. And we have the rule that in front of equal angles in the triangle, there are equal sides. That is to say, EF must be equal to EC. Okay, EF must be equal to EC. In triangle EFC, because of the fact that angle EFC, this angle equals to angle ECF. This angle and they're both equal to theta. And angle EFC because of the fact that angle ECF equals to angle EFC equals to angle ECF and they're both equal to theta. We will derive from it that EF equals to EC. Side EF equals to side EC. EF equals to EC. But we just right now found out that EF equals to 5 units. We know that EF equals to 5 units, and from this equation 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. So we can write here that EC equals to 5 units. Now it is very easy to see from the drawing that DC minus EC equals to DE. Again, DC minus EC equals to DE. DC minus EC equals to DE. Repeat again. From the drawing, it is very easy to see that side DE equals to DC minus EC. So DE equals to DC, that is 6 units according to what is given as the question, minus EC, we just right now found out that is equal to 5 units. So in conclusion, we found out that D equals to 6 minus 5, that is 1. D equals to 1 unit. So we can write down here that DE equals to 1 unit. Therefore, in the right small triangle ADE, the only missing side is the hypotenuse, and we use the Pythagoras theorem in order to find out the hypotenuse in the right triangle ADE. So in the right triangle ADE, according to the Pythagoras theorem, I repeat again that PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, the hypotenuse is AE, so AE squared equals to AD squared plus DE squared. I repeat again, in the right triangle ADE, according to the Pythagoras theorem, AE squared equals to AD squared plus DE squared. AE is the missing side, so we leave it as it is, so AE squared equals to AD squared. AD equals to 3 according to what is given us in the question, so AD squared is 3 squared, that is 9, plus DE squared. DE equals to 1, so DE squared is 1 squared, that is 1. So in conclusion, we found out that AE squared equals to 9 plus 1, that is 10. AE squared equals to 10. We take out of this equation and we get that AE, the missing hypotenuse, AE equals to the square root of 10. AE equals to the square root of 10, so we can write here that AE equals to the square root of 10. And again here, according to rule number 4, that the opposite sides of a parallelogram are equal to each other. So in parallelogram AEBF, according to rule number 4, AE must be equal to BF. In parallelogram AEBF, AE must be equal to EF, according AE must be equal to BF. AE must be equal to BF. AE must be equal to BF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. Okay? But we have already found out that A equals to square root of 10 units. So we can write down here that A equals to square root of 10. And from this equation, square root of 10 equals to AE equals to BF, we derive that BF is also equals to the square root of 10. Okay? So BF here equals to the square root of 10 units. So here it is very easy to see from the drawing that BC minus BF equals to FC. Again, BC minus BF equals to FC. BC minus BF equals to FC. Okay, yeah. FC equals to BC minus BF. So here FC equals to BC. According to what is given us in the question, BC is defined as X. So BC equals to X. And we have already found out that BF equals to square root of 10. So in conclusion, FC that is equal to BC minus BF, it is equal to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. In the next step, from point E, we focus on the isosceles triangle FEC, and from point E we draw perpendicular on FC. From point E we draw perpendicular on FC, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. And we'll define the touching point of the perpendicular from point E and BC as M. So here we have rule number 5. According to rule number 5, the height of the base in an isosceles triangle bisects the base. I'll write it down. The height to the base in an isosceles triangle bisects the base. So I read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here in our isosceles triangle EFC, we know that triangle EFC is an isosceles triangle because FE equals to EC equals to 5. Triangle FEC is an isosceles triangle because of the fact that EF equals to EC equals to 5. And in this isosceles triangle, according to rule number 5, the height EM to the base FC bisects the base FC. That is to say, it divides the base FC into two equal parts. That is to say, according to rule number 5, FM equals to MC. FM equals to MC according to rule number 5. So, and because of the fact that it bisects the base, it means that FC over 2, FC over 2 equals to FM equals to FC. Okay, because of the fact that it bisects the base FC, it means that FC over 2 must be equal to FM and must be equal to MC. Okay, so here so the size of side MC here MC will be equal to MF over 2. MC equals to FC over 2. MC, here MC equals to FC over 2. That is to say it is equal to X minus square root of 10 over 2. So in conclusion, MC equals to X minus square root of 10 over 2. In the next step, we will prove that the right triangle ADE, the right triangle ADE is similar to the right triangle EMC. So why those two right triangles are similar to each other? So I write it down that we will prove that the right triangle ADE, the right triangle ADE is similar, this is the sign of similar, to the right triangle EMC. So why those two right triangles are similar to each other? First of all, those two angles are equal to each other, they are both equal to 90 degrees, therefore they are equal to each other. So angle ADE of triangle ADE equals to angle EMC. This angle, and they are both equal to 90 degrees. I'll repeat again. Angle ADE equals to angle EMC equals to 90 degrees. In addition, we have those two angles, they are both equal to theta, therefore they are equal to each other. So that is to say angle DEC is equal to this angle, this is actually angle ECM, and they are both equal to theta. I repeat again, angle DEC equals to angle ECM, and they are both equal to theta. Finally, in triangle ADE, this green right triangle, this angle equals to 90 degrees, this angle equal to theta. So this angle must be equal to 90 degrees minus theta in order to complete the sum of the angles in this right triangle to 180 degrees. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. So this angle must be equal to 90 degrees minus theta, and for the same reason, in the right triangle EMC, this angle equals to 90 degrees, this angle equal to theta. So this angle must be equal to 90 degrees minus theta. So finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So angle DAE is equal to this angle, angle MEC, and they are both equal to 90 degrees minus theta. I repeat again, angle DAE equals to angle MEC, and they are both equal to 90 degrees minus theta. So actually we prove that all three angles of the right triangle ADE congruent to all the three angles of triangle, the right triangle, triangle EMC. Why? Those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. And those two angles, they are both equal to theta, therefore they are equal to each other. So the right triangle ADE is similar to the right triangle EMC according to angle similarity rule. I will write it down. Triangle ADE is similar to triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive, we will conclude, hence, that AE over EC, AE over EC equals to DE over MC. I'll repeat again. From the fact that triangle ADE is similar to triangle EMC, we will conclude that AB over EC equals to DE over MC. So here AE equals to square root of 10 units, so we substitute A by square root of 10 over AC. EC equals to 5, so we'll substitute EC by 5, and it is equal to DE. DE equals to 1, so we substitute DE by 1 over MC. MC, we already found out that MC equals to x minus square root of 10 over 2, so we substitute MC by x minus square root of 10 over 2. Okay, so here square root of 10 over 5 equals to, we'll move 2 to the numerator and x minus square root of 10 to the denominator, and this is the equation number 2, and we get that 2 over, it is equal to 2 over x minus square root of 10. Here we'll cross multiply this equation, equation number 2, and we'll get that according to equation number 2, square root of 10 equals to square root of 10 times x minus square root of 10 equals to 5 times 2, that is 10. Then is equal to square root of 10 times square root of 10. Now we can divide this equation, equation number 2, by square root of 10. And we get that according to equation number 2, here square root of 10 times square root of 10 is 1, so what is left in this side of equation number 2 is only x minus square root of 10, and it is equal to square root of 10 times square root of 10 over square root of 10 equals to square root of 10. We will add square root of 10 to this equation, equation number 2, and we will get that according to equation number 2, x equals to 2 times square root of 10 units, so in terms of numbers it is equal to 6.32 units. I'll repeat again, the value of line segment x that is also equal to BC, it is equal to either 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. Here, x equals to square root 2 times square root of 10 units, or in terms of numbers it is equal to 6.32 units. We finished with the second method. In the next step I will summarize the lecture. So here in the first method, so maybe I will repeat also on the question itself. We have here quadrilateral ABCD, side AB equals to 5 units, side AD equals to 3 units, and side DC equals to 6 units. BC is missing, the missing side, the variable that we are looking for, that is equal to x. So we want to find out the value of BC that is equal to x. We also know that angle ADC, this angle is a right angle, it is equal to 90 degrees, and angle ABC equals to angle DCB, they are both equal to theta, according to what is given us the question. So, in the first step, we did a construction. We actually extended side AB and side CD by a straight line until they touch each other at this point, point E. We define the touching point or the intersection point between those two line segments A, B and CD as E. So actually we created in this way, by this construction, we created triangle BEC. In this triangle we have two angles that are equal to each other. They are both angle ABC equals to angle EBC equals to angle ECB equals to theta. And we have rule number 1 that is related to a triangle that has two equal angles inside it. So here we have in front of equal angles in the triangle, there are equal sides. Okay? That is to say, in triangle ABC, we have two equal angles, they are both equal to theta, therefore they are equal to each other. And according to rule number 1, in front of equal angles in the triangle, there are equal sides. So in front of this angle theta, we have EB, side EB. In front of this angle theta, we have side EC. And according to rule number 1, EB must be equal to EC, because of the fact that those two sides, EB and EC, are located in front of those two equal angles. They also must be equal to each other. Okay, in triangle ABC we have angle ABC that is equal to angle ECB, and they are both equal to theta. And according to rule number 1, in front of those two equal angles there are equal sides. That is to say, those two equal sides, the two sides that are located in front of those two equal angles are EB and EC. And according to rule number 1, they also must be equal to each other. So EB equals to EC according to rule number 1. Okay, EB equals to 5 plus AE. On the drawing you can see that EB equals to 5 plus AE. So we substitute EB by 5 plus AE. And EC from the drawing, you can see that EC or CE or EC, it is equals to 6 plus ED. Okay, so we substituted EC by 6 plus ED. Here we subtracted 5 from this equation. Here 5 minus 5 is 0, so here AE, we have only left with AE. 6 minus 5 is 1, so here in conclusion we found out that AE equals to AD plus 1. Then we defined ED as A. Again, here ED is defined as A according to our definition. ED is equal to A. Okay, so we substituted ED by A. And we got that AE equals to A plus 1. So here AE equals to A plus 1. We know that ED equals to A according to our definition. We found out that AE equals to A plus 1. Okay. Then we know that EC is a straight line. Why? Because when you, first of all, when you extend a straight line by a straight line, the result must be a straight line. And the result that is CE by extended CD by a straight line, we got side CE, or the result is CE, and CE must be also equal to, must be also a straight line. When you extend the straight line by a straight line, it must be equal, it must be a straight line, therefore CE is a straight line. This is one reason that CE is a straight line, and another reason is because we already related to figure EBC as a triangle. So if figure EBC is a triangle, it means that EC is one side of a triangle. So EC is a side of a triangle, it is absolutely a straight line. Okay, anyway, EC is a straight line. Okay, for a lot of reasons, EC is a straight line, for more than one reason. Okay, so EC is a straight line, and you have rule number 2 that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so according to rule number 2, if we focus on this side of the straight line EC at point D, then the sum of the angles on this side of the straight line EC at point D must be equal to 180 degrees. So which angles we have at point D at this side of EC? We have here 90 degrees and we have angle EDA. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. Okay, at this side of the straight line EC at point D, the sum of the angles must be equal to 180 degrees. We have two angles on this side of ED at point D, we have 90 degrees and again EDA. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation and found out that the missing angle, angle EDA, equals to 90 degrees. This angle, angle EDA, equals to 90 degrees. Okay? And because of the fact that angle EDA equals to 90 degrees, it means that triangle EDA is a right angle. That is to say, we can implement the Pythagoras theorem on the right triangle EDA in order to find out the value of A, that is the only missing variable here. Okay? So we implemented the Pythagoras theorem in the right triangle EDA. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AE squared equals to ED squared plus AD squared. A squared equals to AD squared plus ED squared. AE squared is the missing variable. Also, AE squared equals to AD squared. AD equals to 3, so AD squared is 3 squared, that is 9, plus ED squared. ED equals to A, so ED squared is A squared. So here we got that AE squared equals to 9 plus A squared, but we know that AE equals to A plus 1, so we can substitute AE by A plus 1. If A equals to A plus 1, it means that AE squared equals to A plus 1 squared. So we substituted A squared by A plus 1 squared, and we got that A plus 1 squared, according to equation number 1, equals to 9 plus A squared. Here we open the brackets on this side of equation number 1, and we got that A squared plus 1 plus 2A equals to 9 plus A squared. Here we have A squared on both sides of equation number 1, so A squared will get cancelled. And we also subtracted 1 from this equation, equation number 1. So here we left only with 2A, and here 9 minus 1 is 8. So in conclusion, we found out that 2A equals to 8. We divided this equation, equation number 2, by 2, and we got that A equals to 4, because 8 over 2 is 4. So we found out that A equals to 4. Here we can write that A equals to 4. So if A equals to 4, A plus 1 will be equal to 5. Okay, so here, actually, in this way, we found out that the length of side BE is equal to BA plus AE. That is to say, it is equal to BA, that is 5, plus AE, that is also 5. That is to say, B equals to 10 units, and EC also equals to ED plus DC, that is to say, it is equal to 6 plus 4, that is also 10 units. So here we have an isosceles triangle. Side BE equals to side EC equals to 10 units. Okay, so here we know that in triangle AED, the right triangle AED, the right small triangle, triangle AED, cosine alpha equals to ED over AE. Okay, in the right triangle, triangle AED, cosine alpha equals to ED over AE. So ED equals to 4. So we substituted ED by 4, A equals to 5. We substituted A by 5, and we found out in conclusion that cosine alpha equals to 4 over 5. Okay, we know that cosine alpha equals to 4 over 5. Therefore, we can actually implement the law of cosines here, because we know that the value of cosine alpha, we know that EB equals to 10 units and EC equals to 10 units also, and the only missing variable is BC. So by implementing the law of cosines in this triangle ABC, in this isosceles triangle, triangle ABC, we will find out the missing variable, that is actually x. X is the variable that we are looking for in this question. So by implementing the law of cosines in this right triangle, we will find out the value of x, because x is the only missing variable if we implement the law of cosines in this triangle ABC. So what is the law of cosines? The law of cosines is true in any triangle. If we have triangle ABC that could be any triangle, we know that the length of AB is A units, the length of AC, side AC is B units, and the length of side BC is C units. Then according to the law of cosines, C squared equals to A squared plus B squared minus 2 times AB times cosine alpha. So here we will add 2 times AB cosine alpha to this equation, and we'll subtract C squared simultaneously. Again, we'll add 2 times AB cosine alpha, and we'll subtract C square simultaneously, and we get that here 2 times AB cosine alpha is in this side, C square is in this side, so it will become minus C square. So in conclusion, we found out that 2 times AB cosine alpha equals to A square plus B square minus C square. We divide this equation by 2 times AB, and we get that according to this equation, cosine alpha equals to A square plus B square minus 2 times A square plus B square minus C square over 2 times AB. So we can implement the law of cosines in our triangle EBC. In our triangle EBC, we'll get that here cosine alpha equals to A square plus B square. A is EB and B is EC, so it is actually EB square plus EC square minus C square. C square is BC square, that is actually X square. Again, it is EB square plus EC square minus BC square, that is actually X square. Over 2 times AB is 2 times EB times EC. We know that EB equals to EC equals to 10 units, and we already found out that cosine alpha equals to 4 over 5. So we substituted cosine alpha by 4 over 5, and here EB equals to 10, so EB squared is 10 squared, that is 100. EC is also equals to 10, so EC squared is also 10 squared, that is also 100, minus BC squared. BC, here you can see that BC equals to X, is the missing variable. So BC square is X square. So we substituted BC square by X square. So it is minus X square over 2 times EB is 10, EC is also 10. So here we have 100 plus 100 is 200. So in the numerator we have 200 minus X square. In the denominator, on this side of the equation, we have 10 times 10 is 100, and 100 times 2 is 200. We multiply this equation by 200 to get rid from the numerator. And here we found out that 200 minus X squared equals to 2 times 4 over 5. 200 over 5 is 40, and 40 times 4 is 160. In conclusion, we found out that 160 equals to 200 minus X squared. We added X squared to this equation, and we found out that we added X squared, but we also subtracted 160 degrees. So in conclusion, we found out that X squared equals to 200 minus 160 is 40. So in conclusion, we found out that X squared equals to 40. And then we took a root from this equation. X squared equals to 40. We took a root from this equation, and we got that X equals to square root of 40. 40 is 4 times 10. So we substituted 40 by 4 times 10. And the square root of 4 is 2. So in conclusion, we found out that the length of line segment X, it is equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. The length of this line segment BC, in quadrilateral ABCD, it is equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. Then I presented to you how to find out the length of line segment EC, the length of line segment BC, that is actually equals to X, according to rule, according to the second method. So here we did another construction. here we did another construction. From point A, we drew a straight line on CD. We drew the straight line on CD in such a way that AE will be parallel to BC. This is the first construction, and then from point E, we draw a straight line on BC in such a way that EF will be parallel to AB. In conclusion, by doing this construction, we created side AE that is parallel to BC, and we also created side EF that is parallel to AB, both according to our construction. Both those two line segments were created according to our construction. Okay. Then I presented to you rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. So here we know that AB is parallel to EF according to our construction. AB is parallel to EF according to our construction. Therefore, those two angles are defined as corresponding angles, and therefore they are equal to each other according to rule number 3. Why? Because those two angles that are defined as corresponding angles are located between the parallel lines AB and EC, and therefore according to rule number 3, they are equal to each other. That is to say, angle ABC equals to angle EFC. Okay, according to rule number 3, angle ABC equals to angle EFC, because those two angles are located between the parallel lines AB and EF, therefore they are equal to each other. But it is given as the question that angle ABC equals to theta, so we can write down that angle ABC equals to theta, and from this equation theta equals to ABC equals to EFC, we will derive that angle EFC is also equals to theta. So this angle is also equals to theta. Likewise, according to rule number 3, because of the fact that according to our construction AE is parallel to BC, we know that AE is parallel to BC. According to our construction, we will derive from it that those two angles that are defined as corresponding angles and they are located between the parallel lines AE and BC, they must be equal to each other according to rule number 3, because they are located between the parallel lines AE and BC. That is to say, angle AED equals to angle DCB. Okay, angle AED equals to angle BCD. Okay, angle AED equals to angle BCD, according to rule number 3. But it is given us the question that angle BCD equals to theta. This angle equals to theta according to what is given us the question. So from this equation, theta equals to angle BCD equals to angle AED, we will derive that angle AED is also equals to theta. So this angle AED is also equals to theta, and actually we created here parallelogram. AEBF is a parallelogram. A parallelogram is a quadrilateral that has two couples of sides that are equal to each other. Here AE that are parallel to each other. AE is parallel to BF, and AB is also parallel to EF. Therefore, this is exactly the definition of a parallelogram. That is to say, AEBF is a parallelogram. Okay, this is a parallelogram. And in triangle EFC, this triangle we have also rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. Okay? According to rule number 4, the opposite sides of a parallelogram are equal to each other. In parallelogram ABEF, it means that AB is equal to EF and AE is equal to BF. Okay? So in parallelogram AEBF, AB must be equal to EF according to rule number 4. AE must be equal to BF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. A equals to BF, but we know that AB equals to 5 units. It is given as the question. So from this equation, 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF is also equals to 5 units. Okay? So in the right triangle EFC, in triangle EFC, it is in an isosceles triangle. Triangle EFC is an isosceles triangle because it has two angles that are equal to each other. In triangle EFC, those two angles are equal to each other. They are both equal to theta. In triangle EFC, we know that angle EFC equals to angle ECF, and they are both equal to theta. And we have the rule that in front of equal angles inside the triangle, there are equal sides. So in front of those equal angles, there are equal sides. That is to say, EF must be equal to EC. EF must be equal to EC according to the rule that in front of equal angles in the triangle there are equal sides. EF must be equal to EC. But EF equals to 5 units. EF equals to 5 units. EF equals to 5 units. So from this equation, 5 equals to EF equals to EC, we will derive that EC is also equals to 5 units. EC is also equals to 5 units. Okay? And here, if EC equals to 5 units and DC equals to 6 units, then from the drawing you can see that DC minus EC equals to DE. Okay, here. DE equals to DC minus EC. From the drawing it is very easy to see that DE equals to DC minus EC. Okay. D equals to DC minus EC. DC equals to 6 units. DC equals to 6 units. And EC equals to 5 units. Okay? Here, DC equals to 6 units, EC equals to 5 units. So in conclusion, DE equals to 6 minus 5, this is 1. So we found out that DE equals to 1 unit. So now in the right triangle ADE, the right hand triangle ADE, we can easily find out the size of the length of the hypotenuse AE, because AD equals to 3 units. D equals to 1 unit, and the only missing side is the hypotenuse, and we will implement the Pythagoras theorem in the right triangle AD in order to find out the length of the hypotenuse. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the right triangle ADE will get by Pythagoras theorem PT, the Pythagoras theorem, AX square equals to AD square plus DE square. AE is the missing hypotenuse, so we leave it as it is, and it is equal to AD square. AD equals to 3, so AD square is 3 squared, that is 9. AD square is 9. D equals to 1, so D square is 1 squared, that is also 1. So D square is 1. So in conclusion, we found out that A square equals to 9 plus 1. 9 plus 1 is 10. So in conclusion, we found out that A square equals to 10. Here we take a root out of this equation and we find out that A equals to the square root of 10. Here the hypotenuse AE of the right triangle AD equals to square root of 10 units. Now we have the rule that the opposite sides, rule number 4, that the opposite sides of a parallelogram are equal to each other. That is to say, in parallelogram AE BF, AE equals to BF. Okay? In parallelogram AE BF, according to rule number 4, AE must be equal to BF. But we have already found out that AE equals to square root of 10 units. So from this equation, square root of 10 units equals to A equals to BF, we will derive that BF is also equals to 10 units. Here, BF is also equals to square root of 10 units. This nice segment BF equals to square root of 10 units. And what is the length of FC? It is very easy to say from the drawing that BC minus BF equals to FC. Again, BC minus BF equals to FC. So FC equals to BC minus BF, BC equals to X, according to what is given as the question. BF, we just right now found out that BF equals to square root of 10 units. So in conclusion, we found out that FC equals to X minus square root of 10 units. Here, FC equals to X minus square root of 10 units. Okay, then I presented to you rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. Okay, so here, according to rule number 5, first of all, triangle FEC is an isosceles triangle. Why? Because FE equals to EC equals to 5. So in the the isosceles triangle FEC, the height to the base, that is actually EM. Here, from point E, we actually drew perpendicular on BC. So EM is perpendicular to FC also. So the height to the base in this isosceles triangle FEC is EM, is the height to the base FC. And according to rule number 5, the height EM to the base FC, it is not only perpendicular to the base FC, but it is also bisects the base FC. That is to say, FM equals to MC. And it bisects the base. It means that FC over 2 equals to FM equals to MC. Okay, FC over 2 equals to FM equals to MC. This is the meaning of rule number 5. That it divides the base into two equal parts. That is to say, FC over 2 equals to FM equals to MC. Okay, according to rule number 5. And we have already found out that FC equals to X minus square root of 10 units. So FC over 2, that is actually equals to MC and also to FM, will be X minus square root of 10 over 2. So here MC will be equal to FC over 2, that is actually X minus square root of 2, X minus square root of 10 over 2. So here, again, MC equals to FC over 2, that is actually X minus square root of 10 over 2. In the next step, we proved that those two right-hand triangles are similar to each other. Why those two right-hand triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. those two angles, they are both equal to theta, therefore they are equal to each other. And those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. Why this angle equals to 90 degrees minus theta? Because if this angle equals to theta, if this angle equals to 90 degrees, this angle equals to theta, this angle must be equal to 90 degrees minus theta. For the same reason, this angle must be also equal to 90 degrees minus theta. That is to say, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So all the angles in triangle ADE can go into all the angles in triangle EDC, therefore triangle ADE, the green line triangle, is similar to triangle EDC, EMC, according to angle similarity rule. Okay, here triangle ADE is similar to triangle EMC according to angle similarity rule. And from the fact that the two right great triangles are similar to each other, we will derive that AE over EC, here AE over EC, AE over EC equals to DE over ME equals to DE over MC. Again, AE over EC equals to DE over MC. Okay, AE over MC equals to DE, AE over EC equals to DE over MC. Okay, AE over EC equals to DE over MC. AE equals to square root of 10 units, EC equals to 5, DE equals to 1, and MC equals to x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator, and we regard that square root of 10 over 5 equals to 2 over x minus square root of 10. Because multiply this equation and regard that square root of 10 times x minus square root of 10 equals to 10, but 10 is square root of 10 times square root of 10. Then we divided this equation by square root of 10, and we found out that here square root of 10 times square root of 10 is 1, so we left only with x minus square root of 10 in this side of equation number 2, and in this side we have square root of 10 times square root of 10. So square root of 10 times square root of 10 over square root of 10 is square root of 10. So here we got that x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation number 2, and we found out that x, the variable that we are looking for, is equal to either 2 times square root of 10 units, or in terms of numbers, it is equals to 6.32 units. Okay, so the answer to the question is that x, this nice segment, it is also equals to BC, it is equal to either 10 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.